Okay, hi everyone. Let's get started. Hello, my name is Alan Hudson from the Immuno-Oncology Translational Network Data Management Resource Center. I also serve as chair of Biostatistics and Bioinformatics at Roswell Park Comprehensive Cancer Center. Before we start the seminar, I just have a few bookkeeping items to review. So questions will be responded to at the end of the presentation. Please enter your question in the Zoom Q&A box. The audience can prioritize the order of the question by clicking on the thumbs up button. Closed captioning is available. The closed captioning for today's webinar can be accessed by clicking on the live transcript option in the Zoom menu at the bottom of your screen. Instructions will also be provided in the chat box. The recording of today's webinar will be available in a few weeks after today's presentation. With that, I would like to turn the proceedings over to our moderator, Anne Graham. Anne serves as the founder and executive director at MIB Agents. Anne's interest in pediatric oncology began when at age 43, she was diagnosed with osteosarcoma, a primary bone cancer that affects kids in the ages range from 10 to 25. She was treated in the Pediatric Cancer Center at Memorial Sloan Kettering. She was awed and inspired by the courage and cheerfulness of her fellow patients every day. Like most adults, she was unaware of how little funding pediatric cancers receive and how great the suffering is, and how all too well often the youngest patients lose limbs, fertility, hearing, organ function, and of course their lives to cancer. Anne began MIB Agents in 2012 when a fellow osteo patient, Alyssa Devers, was sent home on a hospice for her same cancer. Anne rallied her friends to create an extraordinary experience for Alyssa and her family in her last weeks of life. Today, MIB Agents Make It Better, MIB, for kids with osteosarcoma through direct patient and family support programs, educational materials and resources, funding research, and through an annual conference, weekly podcast, and webinar. Anne?
Thanks, Alan. Really excited to be here today and for this work to be undertaken by Cancer Moonshot and all parties. I would like to introduce you to our speaker today. Katherine Janeway, MD, MMSC, is a senior physician in pediatric oncology at Dana-Farber, Boston Children's Cancer and Blood Disorder Center. She is an expert in caring for children, adolescents, and young adults with sarcomas. Dr. Janeway's research is focused on genomics, precision oncology, and bone sarcomas. She leads clinical trials in osteosarcoma and Ewing sarcoma as an independent investigator and as chair of the Children's Oncology Group Bone Tumor Committee. Dr. Janeway's work has uncovered the genomic events causing and sustaining difficult to treat childhood solid malignancies. She has leveraged this understanding to expand treatment options and to improve clinical trials for children with advanced childhood solid malignancies. She is part of the leadership team of the first and largest national precision oncology trial in the United States, the National Cancer Institute COG Pediatric Match Trial. In recognition of her achievements demonstrating the utility of sophisticated tumor profiling tests in the pediatric oncology clinic, Dr. Janeway took on the role of Director of Clinical Genomics at Dana-Farber Cancer Institute in 2018. Dr. Janeway's research group is currently focused on better characterizing the clinical impact of genomic sequencing. The main project in her laboratory addressing this question is the ICAT2 GAIN Consortium study, which has enrolled and sequenced over 750 patients with difficult to treat childhood solid cancers. Her group is also contributing to efforts to share and aggregate both sequencing and clinical data to enable a deeper understanding of childhood cancers. In particular, the group has several data generation and sharing projects aiming to better characterize the genomics of osteosarcoma and Ewing sarcoma. With these projects, they hope to identify the clinicogenomic factors explaining prognosis and treatment response and resistance. Such a big deal, you guys. In their Cancer Moonshot project, as part of Count Me In, the group is innovating patient partnerships in sarcoma research, which is the work that Dr. Janeway and we will be talking about today.
Well, thank you so much for that kind invitation, Anne. And I'm so pleased to be here today to speak as part of this webinar series. And I'm thrilled to hear how many attendees there are. So I'm going to speak about the Count Me In Patient Engagement Cancer Genomic Sequencing Center, focused on partnering with patients to define the clinical and genomic landscape of rare aggressive sarcomas in children and adults. These are my disclosures. And this is an overview of what I will speak about today. I'm going actually to start with the people who make this work possible. And it will become very clear why I'm starting with that slide. Then I'll discuss Count Me In, the Count Me In patient partnered research platform developed by my colleagues. I'll discuss the Cancer Moonshot Patient Engagement Cancer Genomic Sequencing Network. I'll explain a little bit to you about osteosarcoma and leiomyosarcoma, and then dive into our study procedures, progress, and preliminary findings from our patient engagement cancer genomic sequencing, Count Me In, osteosarcoma and leiomyosarcoma projects. And then I'll end on a discussion of some of our current priorities and ongoing work for this PE-CGS, Count Me In, osteosarcoma and leiomyosarcoma work. So this is my first slide, and I really want to start by recognizing and thanking patients, families, and advocacy groups without whom the work I will describe today would not be possible. I am showing you Anne's picture because there's a good reason that she's introducing me today. She has been an incredible force behind really bringing to the forefront the patient and advocate voice in the osteosarcoma community, but also sort of creating a partnership between us, the physicians and researchers, and those patients and families and advocates. And it really wouldn't be possible to do the work I'm describing today without that partnership. And so that's why this slide comes first. Next is the Count Me In Patient Engagement Cancer Genomic Sequencing Center team. It's a very large team. We span institutions and organizations. And I'm highlighting for you my co-investigators, but really everybody in the team is necessary to make this work possible. And then I especially want to call out Nick Wagley and Corey Painter, who have really developed a concept that they turned into Count Me In, which I'll tell you about in the next few slides. And both Nick and Corey are sort of the heart and soul of this project, but have moved on to new and exciting roles in the private sector. So what is Count Me In? Count Me In is really a concept or a platform. And the idea behind Count Me In is that physicians and researchers should be in partnership with patients and families impacted by the cancer types that we're studying. And this partnership should really have no barriers or walls. And in fact, the idea was to remove the physical walls from the patient participation in research. And so Count Me In really brings a research experience to the patient in their living room, on their phone, on their computer. And patients are able to access the Count Me In website, select their cancer type, and sign up to be a part of this research and really a partner in this research. The projects have focused on consent for obtaining medical records, tumor and germline material, and conducting sequencing, and then sharing, collecting clinical data from the electronic medical record and sharing that clinical genomic sequencing widely in the research community, but also back to the patient partnered community so that they're very aware of sort of where their research has taken us. At the time that we sort of started our PE-CGS Count Me In Center for Osteosarcoma and Leiomyosarcoma, Count Me In was involved in 6 different cancers, enrolling patients really across the United States and Canada. And in fact, now Count Me In has extended to really allowing a patient with any cancer to enroll. I'm going to start by sharing with you kind of the angiosarcoma project results, really as an illustration for how powerful this platform and concept of patient partnered research can be. So angiosarcoma is an extraordinarily rare sarcoma that made it very difficult to effectively study the underlying sort of genomics of the disease. And so Count Me In launched into angiosarcoma as one of its first cancers. What I'm showing you is the sort of landing page for the Count Me In website for the angiosarcoma participants, which was designed in collaboration with the patients. I'm showing you the map of where all of the angiosarcoma participants lived or resided, and the cover of the Nature Medicine issue where the results of the angiosarcoma project were published. And what they were able to find in the angiosarcoma project, they were not only able to enroll sort of the largest number of patients with this disease that have been studied, but they were able to show that in head and neck angiosarcoma, had generally, or angiosarcoma that occurs in the head and neck, had a higher tumor mutational burden, and enrichment of signature 7. And then signature 7 is correlated and high tumor mutational burden, I think as many of you know, are correlated with response to immune checkpoint inhibitor. And because patients allow us permission to obtain information from their medical records, it became clear by aggregating this patient experience with the genomic data that there were 2 patients with angiosarcoma of the head and neck who had responded to pembrolizumab. At the same time, there was a very large study ongoing enrolling patients with sarcomas into a clinical trial of dual checkpoint inhibition. And that showed benefit of immune checkpoint inhibitor in angiosarcoma, primarily in the cutaneous and head and neck tumors. And so the Count Me In experience not only is in line with these clinical trial results, but also starts to provide a biologic explanation of why that might be the case. So with the angiosarcoma experience, it was clear that this platform was a very powerful platform for discovery in rare cancers and rare sarcomas. But there are certainly, it was relatively early in the Count Me In experience, and like any other research that we do, there were certainly challenges and interest in moving in new directions. So some of the challenges that are experienced in this direct-to-patient engagement experience is sustainment of engagement, and I'll just explain that by showing you this accrual curve of both patients who register and consent, but also germline and tumor material and medical records into the angiosarcoma project. And what you can see is that the number of patients who registered, did surveys and consented is quite high for a rare sarcoma at over 250 participants. But the number of tumor samples received is an order of magnitude smaller than that, under about 100 patients. And so the idea is to try to really sustain that engagement and make sure that we're continuing to involve patients in obtaining tissue material and medical records. The second is return of results. And let me explain what I mean by that. So Count Me In was always planned to be, to have and does provide early sharing of sequencing results in an aggregate form to the research community and also to the patient partners, but has never done individual patient return of results. So actually letting patient participants know what their tumor or their germline showed. And then finally, there was great interest in optimizing outreach to diverse patient populations, and we had some information that perhaps we could do better there. So in the metastatic prostate cancer project, there was a high proportion of rural participants, but a low proportion of non-white participants. And Hispanic and Latino individuals are less than 4% of Count Me In enrollees, compared to about 19% of the US patient population. At the same time, as Anne mentioned, my group had prior experience of returning genomic sequencing results to patients in a collaborative project spanning 13 institutions. And we had shown that such sequencing with return of results could have clinical benefit in terms of helping with diagnostic clarification or identifying opportunities for clinical trial enrollment of molecularly targeted therapy matched to the patient's own genomic profile. Unfortunately, at the same time that we were sort of recognizing these limitations, there was the formation of the Participant Engagement Cancer Genomic Sequencing Network, or PE-CGS, which is a collaborative effort between researchers and participants and their communities, and is part of the Cancer Moonshot initiative. And the idea or the objective behind the PE-CGS network is to promote and support direct engagement of diverse groups of underrepresented cancer patients and survivors, and to address gaps in our knowledge of genomics in rare or highly lethal cancers, cancers with high disparities, and cancers in understudied populations. And we were fortunate to be able to become a part of this 6-institution PE-CGS network. There are 5 institutions conducting projects, and Ohio State University is the coordinating center. I'm showing you here each of the PE-CGS, each of the 5 PE-CGS network members with cancer-focused projects. And between these 5 centers, we will enroll over 3,500 patients and or post-treatment cancer survivors. We're investigating 12 different cancer types, which will all have comprehensive genomic data generated. 4 of the cancer types are rare, 2 are highly lethal, 3 have an early age of onset, and there are more than 3 different data types that will be generated, and that includes sort of multi-omic genomics, demographics, and clinical data from the electronic medical record. There are 3 research centers that are specifically focused on health disparities, and all centers engage understudied patient populations. Obviously, the work that I will talk about for the rest of this is our Count Me In PE-CGS center focused on leiomyosarcoma and osteosarcoma. Our patient population focus is children and adults, and in the adult group, particularly women with cancer. And we're generating whole exome sequencing, whole genome sequencing, bulk transcriptome sequencing, and low passage whole genome of circulating tumor DNA. In terms of our center, the knowledge gaps addressed in osteosarcoma and leiomyosarcoma, which are 2 cancers I'll discuss more in the coming slides, are rare cancers with an early age of onset and populations that are understudied. So just a little bit about sarcoma. So sarcoma is a complex group of rare cancers. Sarcoma represents over 70 distinct tumor types per the most recent World Health Organization criteria. And many of these cancer types occur in less than 1 patient per million patient population. Leiomyosarcoma is one of the most common subtypes of this uncommon group of diseases, representing approximately 20% of soft tissue sarcomas. And osteosarcoma is the most common high-grade bone sarcoma. And even though I've used the word most common, both of these malignancies are quite rare. Leiomyosarcoma has approximately 2,000 cases per year in the United States. And for osteosarcoma, that case number is somewhere between 750 and 1,000 cases per year. They certainly impact populations of interest in cancer genomics research and populations that have been underrepresented in prior cancer genomics efforts, including women and adolescents. And the genomics of these cancers, which I'll delve into it a little bit more deeply, are characterized by chromosomal instability and a high burden of structural variants. And these are genomic features that we have only more recently become adept at characterizing fully. There's been minimal improvement in survival or reduction in treatment-related morbidity in osteosarcoma and leiomyosarcoma, and this is in part due to insufficient characterization of the genomic landscape. So there was an urgent need to generate a large shared database of clinical and genomic data in osteosarcoma and leiomyosarcoma, but it had been challenging to do this so far because of the rarity of the tumor types and other challenges in patient recruitment and the genomic characterization of these tumors. So the goal of the PE-CGS CMI, or Count Me In, osteosarcoma and leiomyosarcoma projects is to engage patients with these rare cancers across the United States and Canada as partners to generate a large publicly available data set of clinical, genomic, molecular, and patient-reported data, which in turn should accelerate discoveries that drive novel treatment strategies, new clinical trials, and new standards of care. So let me tell you a little bit about osteosarcoma and leiomyosarcoma. I'm going to start with the clinical features. For osteosarcoma, the tissue of origin is bone. These are primary bone tumors that arise in the bone. For leiomyosarcoma, these are muscle tumors. And in particular, there are several types of muscle tumors, but leiomyosarcoma in particular shows features of smooth muscle differentiation. The average age of onset for osteosarcoma is 13 years of age, but for leiomyosarcoma is 50 years of age. The location of the primary tumor for osteosarcoma is in the bone, most often around the knee. And for leiomyosarcoma is in the uterus, muscles in the uterus, the extremities, and the retroperitoneum. The proportion of patients with metastatic disease in osteosarcoma is 40% and 50% in leiomyosarcoma, with those being split sort of between diagnosis with metastatic disease at presentation or at the time of relapse. And for both of these entities, cure for metastatic disease, the cure rate is quite low. Chemotherapy is always given for high-grade osteosarcoma and only sometimes given for leiomyosarcoma that's localized, but always given for metastatic disease. And in both entities, surgery is required as part of the treatment whenever possible. As I think all of you know, because you're joining a Cancer Moonshot webinar, several of the advances that have really improved outcomes for patients with cancer in the last 2 decades involve two specialties or areas of work. One is harnessing the immune response to attack the tumor, usually with the use of immune checkpoint inhibitors, although more recently with approaches such as CAR T cells or antibody drug conjugates. For osteosarcoma and leiomyosarcoma, there's pretty much no activity of immune checkpoint inhibitors. The other sort of big development that has really allowed progress in many cancers is precision oncology, which is the use of molecularly targeted drugs in a particular molecular context that really can be transformative for patients. But unfortunately, for both osteosarcoma and leiomyosarcoma, sort of our initial forays into sequencing this cancer have not uncovered obvious targetable drivers. And so precision oncology is not a really successful approach. So why would we, other than the fact that these are sort of rare sarcomas in need of dedicated research, there's another reason why it makes sense to study these two cancers together in a single project, and that has to do with their genomics. So these cancers actually have fairly similar genomics. There is chromothripsis or chromoplexy in the majority of cases, and I'm showing you a number of different ways to look at chromothripsis or chromoplexy. The 2 figures on the left are from osteosarcoma, and the 2 figures on the right are from leiomyosarcoma. But suffice it to say that somewhere between 75 and 90% of osteosarcomas and leiomyosarcomas will have chromothripsis or chromoplexy. Chromothripsis or chromoplexy is really a gene shattering event where the genes sort of fall apart and get stitched back together. And what is correlated with chromothripsis and chromoplexy is a heavy burden of structural variants. And the mutational burden is actually usually relatively low and tends to cluster at breakpoints, places where there have been genomic rearrangements. And you can see this and see that pattern in the circus plot from an osteosarcoma patient, where you can see the chromosomes are arrayed around the outside of this circus plot, and then What you can see with all the lines in the center are places where the genes have broken and been stitched back together incorrectly. So these are incorrect connections. The next circle shows you copy number changes, with red showing too many copies and blue being too few copies of a gene. And then the next circle in the green and orange are mutations. And you can see that the mutations are really almost bystanders. They're clustered at sites of genomic alterations related to these structural variants. In addition, both osteosarcoma and leiomyosarcoma have evidence of homologous recombination deficiency. Homologous recombination deficiency is a sort of insufficiency in the ability to repair DNA. For osteosarcoma signature and leiomyosarcoma signature 3, which is a mutational signature that shows evidence of homologous recombination deficiency, is present in about 30% of cases. There are preclinical data suggesting sensitivity to PARP inhibition, which is the molecular targeted therapy for homologous recombination deficiency. But in both of these cancers, homologous recombination deficiency is not always due to a BRCA mutation, which is the classic scenario in diseases, other diseases where we see HR deficiency. So the biomarker, the potential biomarker for response to PARP inhibition is unclear. And there are ongoing clinical trials of PARP inhibitors in these diseases. So that question about biomarkers will be important. There's one more point I want to make on this slide, which is that for essentially every cancer, every common cancer that you can think of, there are biologic subtypes of the cancer that are associated with treatment response or treatment resistance. And defining those biologic subtypes has been a huge part of the advances made in those cancers. So think about breast cancer, where we have hormone receptor positive breast cancer, we have BRCA deficient breast cancer, and defining those subtypes helped us understand what therapies might be best for patients in those subtypes. So for both osteosarcoma and leiomyosarcoma, we have so far not clearly defined subtypes for these cancers. And it is there's some very preliminary work in both cancers to suggest that there will be biologic subtypes, just like there are in other cancers. So the specific aims of this, Count Me In, PE-CGS, osteosarcoma and leiomyosarcoma projects are to establish a network of engaged pediatric and adult participants with osteosarcoma and leiomyosarcoma who will co-create a shared database of clinical, genomic, molecular, and patient-reported data to enable research. We plan to consent 3,000 participants with these rare sarcomas over the course of the study. We'll collect medical records, patient-reported data, archival tumor tissue samples, and germline samples. We plan to define the clinical genomic landscape of these tumors by analyzing this clinically annotated genomic data from 750 tumor germline pairs and 500 circulating tumor DNA samples, and to share that de-identified data widely to the research community and also as an update to our patient partners. And we'll study and optimize the approach to direct patient engagement in cancer research using both observational and interventional studies with participants in our network, with a focus on rural and minority participants and participants across a range of literacy levels, ages, and stages of development. To do this work, we've organized ourselves, and I'll mention again that we represent 5 institutions. So this organizational structure is extremely important. We have an administrative core that sort of oversees all the work, and then we're organized into 3 units: an engagement optimization unit, a genomic characterization unit, and a participant engagement unit. The participant engagement unit really designs the projects with patients, builds and launches the websites, engages the patients, recruits them, obtains consent, deploys the surveys, acquires medical records and biospecimens, abstracts information from the medical record, and returns individual results. The genomic characterization unit is responsible for generating the sequencing data, up until the final report that goes back to the patient participants, and analyzing and interpreting the data and sharing that data with the public. The engagement optimization unit is focused really on studying our participant engagement and helping us improve and iterate on that participant engagement throughout the duration of the study. And the participants, as I started with the slide about our participants and our patient and advocacy groups, the participants are really at the center of this study. And they really are part of each of these different units. So now I'm going to talk about our study procedures and some of our sort of early findings. So this is a slide about how we actually built the osteosarcoma and leiomyosarcoma projects. The picture on the upper right is a gathering just prior to COVID at the Broad Institute of patients and advocates to sort of, this was actually before the PE-CGS Center even existed, to start to talk about this project and what it might look like. In designing the websites where patients will sort of interact with our project, participants, we form a participant advisory council, and they advise us on everything, including the text content, the colors, the imagery, and are incredibly involved in how we plan our sort of outreach strategy. And this is just showing you the advocacy groups that helped us with the osteosarcoma and leiomyosarcoma websites. This is a screenshot of the lmsproject.org website. And you can see that it has, it has sort of purple colors. It's usually the text and imagery is quite streamlined, including sort of an overview of exactly what's involved in participating and then how long each of those steps will take. In terms of outreach, we conduct outreach online, including Facebook and Twitter. In person, for example, the osteosarcoma project was launched at an in-person MIB Factor meeting, where we were able to communicate quite successfully with the community. We're outreaching to patients using recontact through banking studies, specifically designed for these cancers. And we have physician engagement as a component of our outreach as well. We have a physician engagement committee consisting of about 35 sarcoma clinicians. And we've presented at academic conferences, including the 2022 and 2023 AACR annual meeting. The upcoming ASCO annual meeting will have a poster, so please stop by. And we're submitting an abstract for the 2023 Connective Tissue Oncology Society meeting. I'm showing you on the right sort of a one-page informational brochure about osteosarcoma, and that is used and will be distributed, for example, at the upcoming MIB Factor conference to inform our patient communities about the opportunity to participate. And one interesting thing you can see is that the color scheme is different and the imagery is different. So here the Patient Advisory Council really recommended that we have pictures of patients because that was more compelling. So in terms of study procedures, patients are eligible who have osteosarcoma and leiomyosarcoma of any age, at any stage, and at any time point in their cancer journey. They have to reside in Canada or the United States. Once the patient is eligible and they come to our website, they first register and consent. And then because we have younger patients in the osteosarcoma community, they must also provide those younger patients, if age appropriate, need to provide assent. They then are offered the opportunity to complete the baseline survey. Once they've done that, they get questions about giving us additional permissions. That includes a medical record release and a question about whether they would like to receive what we call shared learnings from their tumor sequencing. And I'll describe that a little bit more in the subsequent slide. Once those additional permission questions are responded to, the participant receives and returns a saliva and or a blood kit with their germline DNA. The research team requests a tumor sample and medical records from the patient's treating institution. Once the germline and tumor samples are received, the following two events happen. The participant is offered genetic counseling and clinical germline testing with return of results, and tumor and normal are sequenced. I'll go into exactly what that looks like on the next few slides. So we, because there are some differences in this project compared to standard return of sequencing results in the clinic, we really need to develop an approach to returning results for our somatic sequencing in these PE-CGS, count me in, osteosarcoma and leiomyosarcoma projects. Let me highlight what those differences are. The first is that in osteosarcoma and leiomyosarcoma, as I already explained to you, actionable variants are very uncommon. Unlike some of our other cancers, we really don't, for most of the mutations that we find in these diseases, we really don't have molecularly targeted drugs that are active. And so tumor sequencing is not really a part of routine care for these patients. The second difference is that results go directly to the patient. The patient is enrolling in the study, giving us, if they give us permission for sort of this somatic shared learnings component, receiving those results directly in an electronic communication. And we have less control over the timeline between when the patient agrees to receive somatic shared learnings and when that result actually comes back, because we need to get the tissue from an outside institution into our pipeline. And that requires first getting the medical records to see, where the patient had a surgery or a biopsy that produced a tissue that could be sequenced. And we need to then make a request to that pathology department. So what we did is that the engagement optimization unit formed some focus groups to receive patient feedback so that we could design our strategy for returning results of somatic sequencing. We had 3 feedback sessions of osteosarcoma family members, osteosarcoma patients, and leiomyosarcoma patients and family members. And we talked about the process and the type of information that should be communicated. And we ended up reframing return of results to sharing what we're learning about your tumor genome, because we felt that the term return of results has a lot of connotation for patients, physicians, families, that didn't really apply to the way in which we were doing this sequencing and how we were providing that information back. So this is a slide on our somatic shared learnings platform. So the sequencing is tumor normal whole exome sequencing performed in a CLIA, not CPA, CAP certified laboratory at the Broad Institute called the Clinical Research Sequencing or CRISP lab. And it has a 21-day turnaround time from receipt of tumor sample to generation of data. We are focusing our report on genes that are sort of known to be recurrently altered in leiomyosarcoma and osteosarcoma. And what you will see in these gene lists, I've highlighted in leiomyosarcoma in bold, those genes that are also commonly affected in osteosarcoma. And you can see that about 30% of the leiomyosarcoma genes are also commonly affected in osteosarcoma. Again, another reason to study these tumors together. And we developed a shared learning letter that I'm just showing you some excerpted text that is really based on these conversations that we had with our patient participants. The introduction to this letter says, we want to share with you some of the genetic information that we found within your tumor samples. Genetic changes found in your tumor that help us to learn more about how osteosarcoma develops and grows are called cancer drivers. Genetic changes found in your tumor that help us identify new therapeutics that might be helpful for people with osteosarcoma in the future are called potential drug targets. And we have sort of different sections where we'll return different types of information about the somatic sequencing. In terms of the germline sequencing that will go back to patients and families, once we receive a tumor and a normal sample, we will then allow a participant the opportunity to engage with in vitae and Genome Medical, which is Invitae's genetic counselor component for pre and post-test genetic counseling. And then once they have their pre-test genetic counseling, they have the option to have an 84 gene hereditary cancer panel performed. Once that testing or that cancer panel is returned, they have the option for post-test counseling. And if a pathogenic germline variant is identified, they have the option for cascade testing for family members. I'm highlighting here the research data to be shared. As I mentioned, we'll be sharing data from 750 paired tumor normal samples sequenced with whole exome sequencing, whole genome sequencing, and bulk whole transcriptome sequencing. And then 500 circulating tumor DNA samples sequenced with low passage whole genome sequencing. We'll have patient-reported data in the form of surveys, sociodemographic data, and clinical data abstracted from the electronic medical record, including both baseline clinical features and biomarkers, treatment received, and patient outcome. So where are we with these projects? This is an accrual curve from the leiomyosarcoma project as of the end of April. And you can see that we've have about 350 patients who've registered, almost 300 patients who are almost 300 patients who've consented and signed their medical record release. We did not start, we launched these projects before we were ready to start obtaining tumor and germline specimens. And so far in the leiomyosarcoma project, we sent out saliva and blood kits in early February. And we've received back about 150 or over half of the saliva kits that we sent out. And tumors in this project have not yet been requested. For osteosarcoma, again, as of the end of April, we've enrolled almost 100, registered almost 100 participants, consented and have releases signed in over 80 participants. And again, did not request saliva or blood until early February. And we've requested about 55 saliva samples and received almost 30 samples back. And we've now requested 32 samples. And I'm not sure exactly what the number is today, but I think we're close to 10 tumors having been received back. As anticipated, the osteosarcoma and leiomyosarcoma projects have given us the opportunity to focus genomic research on two patient populations previously somewhat underrepresented, including women and adolescents. The sex of the consented leiomyosarcoma participants is almost 80% female. And this is a histogram showing you the age distribution of the osteosarcoma patients who are consented in yellow and the leiomyosarcoma patients consented in purple. And if you'll look here, I think one of the really nice things about combining these studies together is that we're even capturing patients with leiomyosarcoma on the youngest age spectrum and osteosarcoma patients on the older age spectrum. And previously, studies focused in these populations would be mostly focused on adults for leiomyosarcoma and on younger patients for osteosarcoma, just because of who typically is sort of running these studies. Consented patients receive care distributed across a number of different institutions. So for osteosarcoma, we have fully abstracted medical records for 31 patients. And in those 31 patients, care at 34 institutions is represented. And for leiomyosarcoma, we've abstracted parts of medical records for 42 patients, and care is represented at 43 different institutions. And while you can see a predominance of the sort of typical sarcoma centers for pediatric patients, including Memorial Sloan Kettering, MD Anderson, Dana-Farber Boston Children's. You can also see a number of other institutions represented, and the same goes for the adult patients with leiomyosarcoma. So we've actually, our engagement optimization unit has already begun to collect some initial feedback in qualitative interviews. They've conducted 9 interviews, 8 in patients and 1 in a family member. We specifically selected potential participants from communities that have typically been underrepresented in the Count Me In projects. And you can see the race and ethnicity distribution, highlighting interviews with Black Hispanic, Black non-Hispanic, Asian non-Hispanic patients. We also tried to target people at different educational levels, including high school graduates without college or technical school education, and a teenager who had only done some high school, which is to be expected, given that they're a teen. In terms of initial feedback from these qualitative interviews, the people who responded had learned about Count Me In, osteosarcoma and leiomyosarcoma projects from Facebook or other online resources or from a doctor. They found the Count Me In website to be professional, not cluttered, to have reliable content, and to make the patients and families feel like they could make a difference and are true partners in the research. And that was wonderful to see, because the goal of developing those websites with our patient advisory councils or communities was to make to have that response to our websites. The motivations for participation were learning more about their cancer, contributing to research that would help patients and families in a similar situation now and in the future, and advancing cures and treatments for osteosarcoma and leiomyosarcoma. We do have room for improvement, though. In terms of outreach, we've been encouraged to engage with patients' doctors, and it's good that we're in the process of presenting at conferences, and we have a physician engagement group already formed. In terms of procedures, we had feedback that a welcome package after enrollment would be appreciated. And that's something we're certainly starting to think about and work on, is how do we give real-time feedback to our patient partners as we work through the various steps that I showed you of the study procedures. Comments on barriers included highlighting concerns about privacy protection. And so that really translates into us thinking about how we explain what happens to the information and the tumors that we generate through this study on our online platforms. I'll just finish up with a couple of slides about sort of ongoing work. The first slide is about our plans to strengthen Hispanic Latino osteosarcoma patient engagement. We formed a stakeholder advisory group of Hispanic Latino individuals who would be potentially eligible for these studies or are already participants. In the Count Me In community engagement team, there is a specific community liaison focused on increasing access to genomic profiling for the Hispanic Latino population in these studies. We are developing and adapting our strategies for enrollment to specifically address the Hispanic and Latino patient community with osteosarcoma and leiomyosarcoma. And we're planning outreach through the Children's Oncology Group Project Every Child, which is a study that, as the name suggests, attempts to enroll every child diagnosed with cancer who is treated at a Children's Oncology Group member, and there are over 250 members of the Children's Oncology Group across the United States and Canada. And through Project Every Child, there are 1,000 enrollees with osteosarcoma, 213 of whom are Hispanic and Latino. We then plan to evaluate the success of these enrollment strategies by tracking key outcomes of enrollment and patient and parent experiences with engagement with Count Me In. In addition, we are focused on interactions across the network, and we're really excited about that. The network functions as a collaborative network to address common issues, share best practices and lessons learned, and utilize common methods when appropriate. If you're interested in learning more about the network, there's a manuscript that's recently been published in JAMA Health Forum. But just to highlight some of the areas where the network is working together: tailoring education and communication with patient partners, optimizing engagement strategies, identifying the definition and measures of engagement, addressing cancer disparities, thinking about how we return sequencing results and what best practices are for that, genomic sequencing and characterization. And one unique aspect of these these projects that I haven't mentioned yet is that all of the sequencing is being done from paraffin material. Data standardization and harmonization, and thinking about ethical, legal, and social implications of our work. And with that, this is my final slide. As for those of you who missed the beginning, I showed my my sort of acknowledgement or collaboration slides in the beginning, because this work is really requires a large team and engagement of patients' families and patient advocacy groups. But I just wanted to also highlight our internal advisory board and our external advisory board, who have been very valuable in the work that was presented today. And I'll finish with this slide, which is an advertisement to please think about Count Me In and becoming part of the work that we do for physicians and researchers. Feel free to go to the website, and I'm showing you some QR codes here, and sign up for our mailing list, join our physician engagement committee, request recruitment materials, and for patients and loved ones, please, consider becoming part of our group, or at least checking out the projects online. With that, I will thank you all for your attention. Thanks again for the invitation to present to this audience. I've really enjoyed telling you about our work.
Thanks, Dr. Janeway. Enjoyed hearing about it. I'm like over here going, yes. Okay, please, everybody who's listening, please understand how extraordinary this moment is. We have a planet aligning situation of doctors, researchers, the government, NCI, NIH, CCR, Cancer Moonshot, patient advisory. I mean, this is an extraordinary moment, and this particular project, and I am not paid by this project, so this is from my heart. This patient-powered research is a gift. If you've ever wanted to be a superhero, let me just remind you what a superhero does. A superhero uses their powers for good. There is no cost to participate in this program. This is a way to help discovery happen, and it is a way to meaningfully reduce suffering in the world. And I can tell you from an organization that one thing that we do, among many things that we do, is we do end-of-life experiences for kids. We put no restrictions on it when we talk to the child, or we talk to the family. And we say, what can we do? How can we help? 9 times out of 10, the answer is find a cure. This is a way that we can all find a cure. So please, please participate in this in whatever space you are occupying. Everybody has the ability to make it better. Okay, so lots of great questions. As they say on the movie Aladdin, phenomenal cosmic questions, itty bitty little bit of time. So I'll stop talking and get to the questions. And we'll start with Lisa. Her question is there a way for patients to send updated information? So once you've began to participate, is there a way to continue to inform Count Me In, Osteosarcoma Project, et cetera, about new information on an ongoing basis?
Yeah, so thank you so much for that question. Currently, the way that our study is designed, the survey is done at entry. We do have the ability to obtain updated information from the medical record. So we could, ask for an update of the medical record. But currently, the survey component is done at the time of entry. We are in the process of forming a patient advisory council. We had one that was formed for the development of the projects, but we feel it's really important now to form another patient advisory council to sort of give us feedback on the experience to date. And so if you're interested in being part of that and asking this question in that context, please feel free to reach out to me. Thank you.
Okay, great. So just to be clear, if somebody, for example, gets genomic sequencing somewhere else from another organization, can they contact Count Me In and say, hey, I got some new intel?
Yes. So if you would like to contact us at the email that I showed, and I'll put that in the chat maybe, you are absolutely welcome to contact us and email us information. That is totally welcome. And sometimes people actually will email us their medical records, which you're also welcome to do. But there isn't, other than us going back to the electronic medical record, there isn't other than the email, there isn't sort of a systematic way for people to continue to provide updates. But I think this is the type of these are the type of questions and the type of information that we're looking forward to hearing back from our patient participants, and working on sort of modifications to our study procedures that really meet the needs of the whole community.
Okay, great. Next question from Susie. Can someone participate if a tumor sample is no longer available? And I'm going to add to that question. Yep. If your child has passed, or your partner or your family member has passed, how can that information still inform the Count Me In project?
Yes, thank you for asking that question. So I'll start with the first question from Susie. So Susie, you can participate even if there is no remaining tumor material. So we would still have your surveys and your electronic medical records, which can be extremely helpful for the project, just to get a full picture of this disease, which there actually hasn't been a large sort of clinical research project in these diseases. So please do sign up, even if you don't think there's tumor available. In terms of the second question, and about patients who unfortunately have passed away from this disease, family and loved ones can go onto our website and register for the project. You will then we'll be keeping track of you and the fact that you're interested in the project. You'll receive updates about the project. Right now, the research involving patients who are pre-deceased before consenting to a research project is a little bit of a gray area in a regulatory in the regulatory space, but we are quite interested in working on that. And again, we're hoping to partner with patients and families to figure out the right way to do that. We want to do that in a way that's respectful of that individual and of their family. But also we think it's extremely important because we want the full picture of this disease. And if we're not able to, of these diseases, if we're not able to really study those patients who unfortunately did not survive the disease, we will very likely have sort of a biased patient population towards those with a sort of better form of the disease. So that's a really important question.
Okay, if I can ask one more really important question as well. Are patients given a choice whether to receive their sequencing information back or not? If they decide they don't want to know, is that a possibility? And thank you, Nathan, for that question.
Yeah, Nathan, that's a great question. So you can participate in the study and not receive any genomic information. And we ask that question several times, actually. So we ask after your initial consent, you get asked if you would like to receive shared learnings. If you answer yes at that time, the next step for the somatic shared learnings is that when you get an electronic communication about those shared learnings, the results are not right there in your face. You actually have to click on it to get to the results, so that you have the second opportunity to decide not to look at it at that time and leave it for another time. And then for the germline, we're not doing shared germline until you've had a genetic counselor meeting where you learn more about germline sequencing and are able to make an informed decision about that.
About one more, Ann.
So many questions. I don't know.
Yes.
Oh, the pressure. Sharing. There are concerns about security. What do we say about that? Because that's one of the first things that somebody asked me about when I'm talking about this project, like, yep. Okay, all this information on the internet kind of thing.
Yeah, it's a great question. So there are some standards in the sort of genomic and clinical research arena regarding how we share information to ensure that we protect privacy. And so we, for example, we don't share information if we have too few participants with a particular clinical feature. We won't share that clinical feature because if we share that clinical feature, that participant then becomes sort of inherently identifiable just because they have a very rare location of the tumor, for example. So we have some standards that sort of help protect privacy. The other way that we protect privacy is that we control access to information. So when we have the type of information that we share sort of on the internet more broadly is limited. It's limited in a way that prevents identifiability. And then the next layer of access where, for example, an investigator wants the sort of detailed sequencing files, they have to go through some steps. So they need permission they need their institutional certification that they are, doing that kind of research. They need to be a certain type of person. And so we have standards in place that are there to sort of ensure privacy and protect privacy.
So with that, I think we're at the top of the hour. Thank you, Anne, for your excellent moderation. Thank you, Dr. Janeway, for an excellent webinar. Look forward to next Moonshot seminar, the molecular role of NUP98 fusion oncoproteins in pediatric leukemias by Dr. Kowacki from St. Jude Children's Research Hospital. Thank you again, everyone.